Scientists thought they knew what they were looking at when 3I Atlas first appeared racing through our solar system, just another chunk of space rock from the void between stars. Right? Wrong. The James Webb Space Telescope just shattered that assumption with data that's making astronomers question everything they thought they knew about interstellar objects. Deep inside this mysterious visitor, something is pulsing, glowing, and responding to signals in ways that defy every natural explanation. The object isn't just moving through space. Something inside it appears to be very much alive. But what could survive the frozen darkness between stars for thousands of years? And why is it headed straight for us? The discovery that changed everything. July 2025 started like any other month for astronomers scanning the night sky. The Atlas survey team in Chile was doing their usual work, tracking asteroids and comets that might pose a threat to Earth. But on July 15th, something appeared on their screens that made everyone stop what they were doing. Moving faster than anything they had seen before, a new object was racing through space at incredible speed. They called it 3I Atlas, marking it as only the third interstellar visitor ever spotted entering our solar system. The first clue that this was no ordinary space rock came from its speed and direction. While most objects in our solar system follow predictable paths around the Sun, 3I Atlas was moving in a straight line from deep space. Its velocity was staggering, far too fast to be captured by our Sun's gravity. This meant it had to come from somewhere else, from the vast emptiness between the stars. The Discovery team ran their calculations over and over, but the numbers were clear. This visitor was not from our neighborhood. What made 3I Atlas even more unusual was its timing. The only other confirmed interstellar objects we had seen were Oumuamua in 2017 and 2I Borisov in 2019. Finding a third one so soon was unexpected. Most scientists thought these visits happened maybe once every few years, but here was another one, and it was behaving differently from the start. Unlike 2E Borisov, which looked and acted like a normal comet, 3I Atlas was already showing signs that something was very different about it. The object appeared much brighter than it should have been for its estimated size and distance from the Sun. Even from billions of miles away, it was glowing with an intensity that made experienced astronomers scratch their heads. The initial images showed a compact, bright core surrounded by a faint haze, but nothing like the flowing tail that comets usually develop when they get close to the Sun. The Discovery team knew they had found something special, but they had no idea just how special it would turn out to be. The infrared mystery unfolded when the James Webb Space Telescope turned its powerful infrared eyes toward 3I Atlas in early August. The operators expected to see the usual signs of a comet warming up as it approached the Sun. Instead, they found something that defied explanation. The telescope's sensitive instruments detected a concentrated glow coming from deep inside the object, burning bright and steady like a lighthouse in the darkness of space. Dr. Lena Marovich, leading the Webb instrument team, watched as the data came streaming in. The infrared readings showed a white-hot core that stood out clearly against the surrounding material. This was not the scattered, diffuse glow they expected from ice and dust being heated by sunlight. Instead, the heat signature was focused and intense, coming from a source they could not directly see, but that was clearly there, buried in the heart of 3I Atlas. The team ran every calibration check they could think of. They looked for instrument errors, solar flare interference, and any other technical problem that might explain what they were seeing. But the readings came back clean every time. The heat was real, and it was coming from inside the object. Even more puzzling was how steady it remained. Normal comets flicker and change as they tumble through space, their surfaces heating and cooling as different areas face the Sun. But 3I Atlas glowed with an unwavering consistency that seemed almost artificial. The temperature readings were 3 times higher than any model predicted for an object of this size at this distance from the Sun. The Webb team compared their data with observations from Hubble and the TESS satellite, and all the instruments agreed. Something inside 3I Atlas was generating its own heat, independent of solar warming. The implications were staggering. No known natural process could explain this level of internal energy production in what should have been a cold, dead chunk of rock and ice from interstellar space. The brightness that should not exist. While the infrared teams were puzzling over the heat signature, optical astronomers were dealing with their own mystery. 3I Atlas was simply too bright for what it appeared to be. Telescopes around the world tracked its steady glow as it moved through space, and none of the observations made sense according to standard comet behavior. The brightness measurements showed something that violated basic physics as astronomers understood it. An object this far from the Sun, still beyond the orbit of Jupiter, where sunlight is weak and distant, should have been barely visible even through the most powerful telescopes. Yet 3I Atlas shone, with the intensity of a comet, much closer to the Sun and much larger than its estimated size. The light was not just bright, it was impossibly bright for its circumstances. Even more confusing was how stable the brightness remained. Comets typically brighten and fade in unpredictable patterns as they tumble through space. Different parts of their surface catch sunlight at different angles, creating a natural flickering effect. But 3I Atlas maintained an almost perfectly steady output, varying by less than 1% over weeks of observation. Its rotation period was measured at exactly 6 hours, regular as clockwork. But this rotation created no visible changes in brightness. The search for a comet tail turned up another anomaly. Instead of the streaming plume of gas and dust that characterizes active comets, 3I Atlas was surrounded by a tight, teardrop-shaped envelope that looked more like a protective shroud than a typical tail. Even at 6 astronomical units from the Sun, where most comets remain completely dormant, this object was already active and glowing. The optical teams ran every test they could think of, but no model of solar heating or normal outgassing could account for what they were seeing. The mechanical heartbeat, the breakthrough that would change everything, came when infrared analysts began looking more carefully at the timing of the heat emissions from 3I Atlas. What they discovered was so unusual that they initially thought their equipment was malfunctioning. The thermal energy pouring from the object's core was not random or chaotic, but followed a precise, repeating pattern that pulsed like a heartbeat. Every 4 hours, almost to the second, the central glow would swell and then fade in a slow, deliberate cycle. The pattern was unmistakably artificial in its precision. Natural processes in space tend to be irregular and unpredictable, influenced by countless variables like solar wind, cosmic radiation, and internal chemistry. But this pulse was as regular as a metronome, unaffected by external conditions or the object's movement through space. Dr. Alina Marovich and her team mapped these pulses against every natural cycle they could think of. They checked the object's rotation period, its distance from the Sun, variations in solar wind pressure, and even gravitational effects from nearby planets. Nothing matched the 4-hour rhythm. The heat appeared to be generated by something deep inside the object that operated independently of outside influences, something that maintained its own internal schedule. The precision of the timing was what made it so remarkable. Over weeks of observation, the pulse never varied by more than a few seconds. This level of accuracy was unprecedented in natural astronomical phenomena. Even the most regular pulsars, those spinning neutron stars that act as cosmic lighthouses, showed tiny variations in their timing. But 3I Atlas maintained its rhythm with the consistency of an atomic clock, suggesting a level of internal organization that defied conventional explanation. Messages from the void. While infrared telescopes were tracking the thermal pulse, radio astronomers were making their own disturbing discovery. The Allen Telescope Array in California, led by Dr. Kavita Ralph, had been monitoring 3I Atlas across multiple radio frequencies, looking for any electromagnetic activity that might explain its unusual behavior. What they found was a signal that should not have existed. Hidden in the cosmic background noise was a faint but unmistakable radio pulse, repeating every 4 hours in perfect synchronization with the thermal heartbeat. The signal was narrow-band and highly focused, cutting through the static with surgical precision. This was not the broad-spectrum radiation that natural objects typically emit, but something that looked deliberately crafted and transmitted. The Discovery team spent days verifying their finding. They checked for interference from satellites, radio telescopes, and even microwave ovens in nearby buildings. Independent radio observatories in South Africa and Australia confirmed the signal, ruling out any local source. The pulse was definitely coming from 3I Atlas, and its characteristics were unlike anything in the Natural Radio Astronomy catalog. What made the signal even more intriguing was how it responded to environmental changes. As solar wind conditions fluctuated, the radio pulse showed subtle shifts in timing that perfectly matched space weather data from monitoring satellites. This suggested that whatever was generating the signal was actively monitoring its surroundings and adjusting its output accordingly. The implications were staggering. Natural radio sources do not typically show this kind of environmental awareness. The technical analysis revealed other unusual features. The signal showed signs of error correction, a technique used in modern digital communications to maintain data integrity over long distances. The frequency stability was far beyond what random natural processes could maintain, and the pulse structure contained mathematical patterns that seemed too organized to be coincidental. Radio astronomers found themselves confronting the possibility that they were not just observing a signal, but intercepting a transmission. The moment everything accelerated. The morning of August 18th brought news that made the 3I Atlas mystery even deeper. Observatories around the world reported a sudden brightening event that seemed to come from nowhere. In less than an hour, the object increased its light output by 40% across all wavelengths, from radio to infrared to visible light. Every instrument pointed at 3I Atlas registered the same dramatic spike in energy. The flare was not gradual like the warming of a comet approaching the sun, but sharp and immediate like someone had suddenly turned up the power on an internal energy source. For a brief window, 3I Atlas radiated more energy than some small stars, pouring heat and light into the surrounding space at levels that dwarfed anything seen from previous interstellar visitors. Then, just as quickly as it had begun, the surge stabilized at a new, higher baseline level. But the real shock came when orbital mechanics teams analyzed the object's trajectory. Marco Macelli and the European Space Agency Near-Earth Object Group discovered that 3I Atlas had not just brightened, it had changed course. The predicted path that had been calculated from months of careful observation no longer matched reality. Instead of continuing on its original trajectory, the object had shifted its direction, bending its path closer to the plane of our solar system. The timing of these events was impossible to ignore. The brightening flare and the course change had occurred simultaneously, locked together in the data logs like cause and effect. Comets can sometimes change direction due to outgassing jets, but the forces required for this maneuver were far beyond what any natural process could generate. The acceleration was deliberate and controlled, suggesting a level of active navigation that challenged every assumption about interstellar objects. Composition unlike anything known. When spectroscopy teams finally got clear readings from 3I Atlas, what they found challenged the fundamental assumptions about what interstellar objects should be made of. Carrie Liss and her group at Johns Hopkins analyzed the light spectrum bouncing off the object, looking for chemical signatures that would reveal its composition. What they discovered was a mixture of the familiar and the impossible. The expected materials were there: water ice and carbon dioxide that characterize most comets, along with rocky silicates and organic compounds typical of objects formed in the outer reaches of star systems. But layered on top of these normal ingredients were absorption lines that refused to match any known catalog of natural materials. Some of the spectral features corresponded to rare Earth elements and metallic alloys that on Earth are only found in advanced manufacturing processes. Even more puzzling were several absorption lines that match theoretical quantum materials, described in physics papers but never observed in nature. These were substances that required precise atomic engineering to create, materials with properties that could only exist under highly controlled conditions. Finding them in what should have been a natural chunk of interstellar debris was like discovering computer chips embedded in a meteorite. The reflectivity profile showed a surface that was far more complex than typical space rocks. Instead of the rough, irregular texture expected from billions of years of cosmic weathering, parts of 3I Atlas appeared smooth and geometrically structured. Some sections reflected light with the characteristics of manufactured surfaces, while others showed the random scattering typical of natural material. The object seemed to be a hybrid of organic and artificial components, as if someone had built a machine and then covered it with a layer of cosmic debris. The signal that changed everything. By late August, the mounting evidence had convinced some researchers that 3I Atlas might be more than just an unusual natural object. The Search for Extraterrestrial Intelligence Working Group, led by an anonymous coordinator, made a decision that would have seemed impossible just months earlier. They would attempt to communicate with the object directly. The transmission was carefully crafted to avoid any possibility of misunderstanding. Instead of complex language or cultural references, the message consisted of pure mathematics, universal concepts that any intelligent civilization should recognize. The signal included prime numbers, the periodic table of elements, and basic physical constants like the speed of light and gravitational attraction. These were the fundamental building blocks of physics, the same throughout the universe, regardless of who might be listening. The message was broadcast from multiple radio telescopes simultaneously, focused directly at 3I Atlas as it continued its approach toward the inner solar system. The transmission lasted for several hours, repeating the mathematical sequences over and over to ensure that any receiving system would have multiple opportunities to recognize the pattern. Then came the waiting, as scientists around the world wondered if anything would respond. 72 hours later, the answer arrived. Radio telescopes detected a narrow-band reply coming directly from 3I Atlas, timed to the second and matching the original transmission window exactly. The return signal was distorted and brief, filtered through whatever system had generated it, but its pattern was unmistakably artificial. Someone or something had received the message, understood it, and chosen to respond. The implications sent shockwaves through the scientific community. For the first time in human history, there was credible evidence of communication with a non-human intelligence. The signal was immediately classified, and access to the raw data was restricted to a small group of government officials and senior researchers. But word leaked out anyway, and speculation began to spread through academic circles and online communities. The age of wondering whether we were alone in the universe was coming to an end. As 3I Atlas continues its approach toward Earth, every major observatory is preparing for its closest passage in late September 2025. The data collected during this flyby will be the most detailed ever obtained from an interstellar object and may finally provide definitive answers about what we are dealing with. Whether 3I Atlas proves to be an unprecedented natural phenomenon or humanity's first confirmed contact with extraterrestrial technology, its arrival has already changed our understanding of what might be possible in the vast darkness between the stars. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.